So we're gonna first find the inverse function for this one right here. We're gonna find the inverse algebraically. We're gonna have to identify the transformations and sketch. And have good vocabulary, give or take. So with the work shown here, we're gonna wanna interchange the x and the y. We're gonna wanna solve for y, which is get it all set up like this because we want everything. We want to isolate the log portion, so we bring stuff over to the other side, and then we divide by 3. And then for the log, we want to write an exponential form. And in order to do that, this is the type of a formula we'll be having to set up. Then after that, we have it set up like this. And last but not least, we have to divide by 4. No, we have to bring the positive 16 and turn it into a negative 16 over here, which is right there. And then have the 4y divided by 4. Have that. And our final answer should look something like this. 5 to the x plus 2 divided by 3 power minus 16 divided by 4 equals y. And that, theoretically, is our inverse. All that's left is to change this. No, it's to graph this alongside its inverse. And this is what I got. This being the inverse, because this is the original one. The 3 in the log is going to vertically stretch it. The 4b, well, this is the real equation that really helped me graph it, because all I did was factor out the 4, and that way I got x plus 4, which is technically a negative 4, because it's going left. It's going right, because it's a negative value. It's going right 4. And also when I graphed it, and I typed it in the same way, I got the same thing, both with sketch and graphing it with a calculator. So 4 is the b value, horizontally compress it. 2 is bringing it down by 2. And then the vertical asymptote is x equals negative 4. And the domain is that. Yes. And that's all. The thing we have to do is find the log properties, and that's simple. Log properties are product property and quotient property. So basically, anything divided is subtracted, and they become their separate little logs. Anything multiplied becomes added. Very simple. And the last part that would really cause any trouble is basically the exponent always goes in front of the log when you want to fully expand it. Same goes for this. You have to rewrite this into a logarithmic form, which basically whatever the power of the x is, and then whatever it's trying to be rooted by, or squared, or whatever, is basically brought up. The number with the x inside is on top, and whatever it's being rooted or squared by is on the bottom. So the final answer, theoretically, or not theoretically, actually is 5 log w plus 5 over 6 log x plus log parentheses y plus 2 parentheses minus 1 over 8 log r. And we went over the properties and required when used, and we've expanded it correctly, and I basically read off the notes. Okay, for the last part, we're going to be solving this equation. We first write it out. We first have to subtract 6 from both sides. Then after that, we have to divide both sides by 3. And then write the ln, or the little e. Now that's been next to the 3 this entire time. We have to write that in natural log or in a logarithmic form. And then after that, ln 4, natural log 4, is equivalent to 1.386, and we proceed to subtract 9 from both sides and solve for a, leaving our final answer to be A equals negative 1.088. Alright, for our final part will be part 3, and it's to solve that equation, logarithmic equation. So what we're going to first want to do is cancel log base 12 on both sides. Then after we do that, we add 1 to both sides. And then after doing that, we proceed to move everything to one side and set equal to 0. After that, we factor and solve for v, and our final answer was v equals negative 6.